Converting. Okay, so I think I mentioned yesterday that you should have these on your study sheet, and that I may at times ask you to convert something and it might not be here. I'll try my best to then provide you with it on the question. If it's something, and if it happens on an AC, raise your hands like Mr. Dirksen, you've never given this one, you never gave this to us, right? And if enough students say that, I'll be like, no problem, here it is, right? Take it. Okay. So linear distances, imperial, right? Then we go imperial to metric. Anything with meters in it is metric. And then you have your grams, right? For mass, and you have your milliliters, and so for liters for volume, right? So I don't really need you to remember that, I hope, but just know the difference. These are basic here. So these are all one-dimensional, right? Or at least there are no squared units. This is preparing you for grade 12, this step right here. And also, we do cover this later on in greater detail. But 1 squared meter, right? I want you to know that you should technically consider this as a bracket right there. So 1 meter squared, okay? What if I asked you, hey, I would like you to tell me this in centimeters? So you replace that part with how many centimeters are there in a meter? Right here. I think you all knew that. Okay. So you're replacing that with 100 centimeters, and the squared stays with you though. Okay. Because now we're looking at area, right? So it's 100 centimeters by 100 centimeters, right? And so what's 100 times 100, right? 10,000, right? You just square that, and so really you squared the actual value, and you also squared the unit, right? So it's 10,000 square centimeters. So a lot of times I have students say, hey, 1 squared meter is just 100 squared centimeters, and that's not true, right? You got to take the whole thing and square it. A squared yard, let's say you wanted that in feet. So you kind of consider that, okay, that's 1 yard. How many yards are there? How many feet in a yard? Right up here, 3 feet. So it's almost like you take 3 feet and you square it. 3 squared is 6, obviously. No, 3 squared is 9, right? That's not funny, Mr. Erickson. Stop doing that. Okay. So a squared yard is like saying 9 square feet, right? Because you have 3 feet by 3 feet. Like imagine area, right? And then 1 square foot, what is that in inches? What would that be in squared inches? Well, you know that 1 foot has 12 inches, but you need to now consider the area that it would cover, right? 12 inches by 12 inches. What's 12 times 12? IPR review. 144, right? Yeah. There we go. So we've got this. This would be areas, right? Areas, 2D, right? 2-dimensional. And then we have volume, which is 3-dimensional. And we'll do the same thing. I ask you, hey, a cubic meter. So cubic, you're thinking a cube, right? That measures 1 meter by 1 meter by 1 meter. So you would say, well, it's 100 centimeters cubed. Okay. And so there you have 1 million, right? So we're using the basic facts up here and making new conversion rates, right? And so 1 cubic yard, if you wanted that in feet, this one is big. This one, even in grade 12 applied, this one right here. I know that there's 3 feet in a yard. What's 3 to the power of 3? 3 times 3 is 9, times another 3 is 27, right? So 27 cubic feet. And then if you wanted feet and inches, well, I know that 1 foot has 12 inches, right? And so you cube it. And I'm going to highlight things in these boxes in a bit so you see the pattern. And that is 1728 cubic inches. So if you want on your study sheet, you can write down the intermediate step, but you could also just write down, right, 1 cubic meter has this many cubic centimeters, right? 1 cubic yard has 27 cubic feet, and so forth. Okay. So what about the highlighting here? Right. I'm just going to say that we replaced 1 meter with 100 centimeters, right? We knew that 1 yard had 3 feet and 1 foot had 12 inches, right? And then the exponent, right? The exponents, they were applied to that linear conversion rate. Same here, right? So the yard, because, right, 1 foot and 12 inches, it's actually the exact same thing. It's the same length, right? So we're replacing the foot with inches, the equivalent in inches, and then we apply the exponent to the whole thing. There we go. So this is kind of foreshadowing, right, what's coming in grade 12 and later on as well when we do some of the renovation types of questions, okay? If I ever am not recording, if it's paused, let me know, okay? Sometimes I teach and I forget to hit record. Okay, so we're going to do some basic one-dimensional conversion here. And I know that you've learned it in various ways. I know that, right? So this is just one way of doing that. So if I go from miles to feet, I start with this, 200 miles, and then I multiply it by a rate that's going to get me to feet, okay? So basically, you want to make sure that you have something that gets you from miles to feet. So what would that be? You go up here, check this one. 1 mile has 5280 feet. Okay? So watch this. This is important. 1 mile, I'm going to put that down here. And I'm going to put 5280 feet in the numerator. This is called a one-step. I call these a one-step. This is a one-step scenario. Why would I put the mile in the denominator? So that it cancels out the miles in the numerator. That's why I'm doing that. So before I cancel that out, right, I'm just going to say, hey, that's why I did that. So it's important to put them in the right place so that you can cancel out. And so it's 200 times 5280. So all you're left with is feet. That's important to notice. Okay? And so that would be 1,056,000 feet. So there's a one-step conversion. And I know that at times you're going to take a different path. And we're going to be slightly off. Just slightly off. That is okay. But you show me the steps. Okay. Centimeters to feet. So watch this. I start with what I'm given, and then somehow I'm going to go to feet from that. Okay. So what would you do here? I will multiply it by, do I have something that takes me straight from centimeters to feet in what I've given you? Actually, you do. feet, centimeters right there. Do you notice the pattern, right? A foot has this many meters, a foot has this many centimeters. So it's basically just multiplying this by 100, right? And then you get, so they're very, very close. So I'm just going to put the 30.48 centimeters here, and the 1 foot goes up here. And again, the whole idea behind this, and I know this is review. Some of you are like, I got this, right? But we're going to up the intensity in a bit, so don't get too comfortable, okay? What I do here, I'm gonna make sure you understand this. You should multiply everything that's in the numerator, and that in this case is very easily done, right? It's just 347 feet, right? Because it's 347 times 1, and then you end up with 30.48. Doesn't have any units, right, in the denominator. All you're left with is feet. And that's at the end where I would say you divide. Oh, I need to use the calculator you're using. So it's good to write 347 divided by 30.48. And that is 11.38 feet, right? 2 decimals is standard. If you do more than 2, unless it's a dollar amount has to be 2 decimals. No questions about that. But if it's anything else, if you do more than 2, as long as you round correctly, you're okay, right? But I will most of the time I'll round to 2. That's the provincial standard, right? The provincial exam will, and there's some notes here. Make sure you show your work, because there are multiple ways to get to your final answer. Okay. Millimeters to inches. How would you do that? Well, 2745 millimeters. I start with that. I just know that 1 centimeter has 10 millimeters. Okay, I'm just going to go with that. So that would effectively cancel out the millimeters, but you're left with centimeters, right? You still need to do one more step. Which one could you use there? Look up on your charts there, right? And I see that 1 inch has 2.54 centimeters. You see that one? At least I'm pretty sure I gave you that, yeah. So that allows you to cancel out the centimeters here. And I'm gonna highlight this as well, right? This went with that. And then the centimeters canceled out with these centimeters. Okay. This is like the unit analysis, right? You want to make sure you show the work. Don't just come up with an answer, right? You need to show your work. It's just like when you talk to someone, you don't just say, you know, water. It's like, no, pass me some water, or right, I'd like to have some water. So 27.45. Okay, I'll get there. Okay, times, why would I go times 1, right? Mr. Erickson, way too much work. Anyways, 27.45 is what you get in the numerator, because trust me, this gets uglier later on. What are you left with in the numerator? Inches, right? And the denominator, I go 10 times 2.54. Why would you use a calculator for that, Mr. Dirksen? I don't know. There are no units left in the denominator, so that's exactly what you want. And so your last step, watch this. This is the cool part. Maybe this is why I use my calculator for it, to show you this part. Arrow up, so 27.45, hit enter. It copies and pastes it. Then I go divide it. I go arrow up, hit enter, right? That's how you paste it, right? And then hit enter one more time, and you get your answer there. So it's 1.08 inches. So I'm getting you to use the calculator just to figure out those features, right? And you can go up many lines, right? Oh, that number, yeah, 108. I'm going to paste that, hit enter, right? It copies and pastes it, and then you do whatever you want with it, minus, plus, you name it, right? Watch this. You can also copy a whole set of operations, like the whole line. Like if you want to copy this down, it's like, actually it was 27.35, right? And then you recalculate just like that. Yeah. And so what does this mean, Mr. Erickson? This means that when we're working through our problems, I'm going to expect you to use all decimals as you're working through the problem, okay? You don't round to 2 and then round to 2 again, and then you're rounding too early, which is going to affect your final answer, okay? All right. It says round to 4 decimals as you work. However, we have calculators that allow us to use all of them. Round final answers to 2 decimals. Discrete data, you round to whole quantities. What's discrete data again? Something you can count in whole units, like number of coins, number of cans, right? Number of people, that's all discrete data, right? Anything you can measure, that's called, what's the word? Discrete versus, starts with a C, continuous. So anything you can measure is continuous, right? Okay, let's keep going here. Okay, I need to watch my time here. Next page. So, squared units. I don't like where this is going, Mr. Erickson. Scary, right? If you're just careful, you should be fine. So watch what I'm going to do. You want to go from squared inches to square feet. So just focus on inches and feet at first. So we're going to go like this, 547.2 squared inches times if you want to go from inches to feet or feet to inches, you would use this one, right? 1 foot has 12 inches. Okay. But if you want to go square inches to square feet or vice versa, you can't use this one as is. So watch this trick. You want the 12 inches to be here. You want the 1 foot to be there. Can you cancel this out with that right now? So you raise this whole conversion rate to the power of 2, right? Because it's in squared units. And then I'm going to copy whatever I have and say 12 inches squared is 144 squared inches, and 1 foot squared is just 1 square foot, which is exactly what you want. Now you can cancel these out. That's all there is to it. It's that extra step. You didn't do this in IAPR, did you? What is IAPR, Mr. Erickson? Intro to Applied and Pre-Calc. I don't think so, right? If you had me, maybe I would have thrown in some bonuses here and there, but that's okay. You'll be fine. So what do you do now? You multiply the numerators, so you get 547.2 square feet over 144 nothing, sorry, just 144. And you might think, like, I could just type this all in one shot, Mr. Dixon. Why do you bother? I know, but down the road, you're going to have maybe 2, 3, or 4 things in the numerator and also a bunch of things in the denominator. So I want you to multiply everything out, come up with a value, then multiply the denominators, and come up with that. So 547.2, sorry, I need to be on there. 547.2 divided by 144, so that's 3.8 square feet. Okay. I want you to try this one next door, right to the right. It's cubed, right? I want you to try that, and I'm going to take a little break here. Calculator, right? Let's see how you do. So I start with what I'm given, and I want to go to yards, meters to yards. Okay, I'm kind enough to just put that right here. So I need to make sure I put the yards up here and the meters go down here, like so. Can't cancel it. I hope that at least right now will make sense to you. It can't cancel it as is. So I need to raise this whole thing to the power of, 3. And so I'm going to do one more line. This is 1 cubic yards, right? And that, right, you take your calculator, 0.9144. I talked about the hat, right? I really think this calculator should have to the power of 3. I'm surprised that they don't get to it, but you want to go to the power of 3, and then on paper you're allowed to do this, right? Just write down 2 or 3 decimals, but you're telling me I'm using all of them, okay? And that would be cubic meters, and that you can cancel that out, right? And you end up with 9.87 cubic yards over 0.764 cubic meters. And so now that you have that on your calculator, you just go 9.87 divided by, copy paste, right? If you don't know how to do that, because I might go a little fast, talk to me, right? And we'll get you set up. So that's 0.91 cubic yards. Okay. All right. How was this? Was this okay? You able to do it? Of course, you're smart. Okay. All right. Let's keep going. So this is not going to be as common at first, but I wanted to introduce that already. Okay. Next, what is different here? We are converting rates. Okay, we're not just converting a measurement, we're converting rates. So rates have different units. Okay, so when you're driving, right, 100 kilometers an hour, 60 kilometers an hour, or now 30, right? September is back, so you gotta watch out for the school zones, right? So 40, you do the same thing, you just have to watch out for the units and how they cancel out accordingly. 42 gallons per minute is basically saying 42 gallons every minute for every 1 minute. Okay, so I don't know why, but I tackle this one first, the gallons. Okay, so I want gallons to be liters, right? See that? Gallons, liters. So I'm going to say, okay, I know that 1 gallon has 3.79 or 7.8? What did I give you? 7.9, right? 7.9 liters. Okay. And why don't we cancel them out already? So I'm just going to say, hey, gallons goes with gallons. Cancel, cancel. We love canceling things out, right? So I have liters in the numerator, good. But I need to tackle the minutes, right? I want to get 2 hours, right? So 1 hour has, I want to cancel out the minutes, so I need to put the minutes in the numerator. Okay, so minutes go with minutes. See, when you go through your notes, isn't that much easier to see what you did, right? Boom, boom, that's gone. And so now I want you to multiply out everything in the numerator, and I kind of skipped that part on my So I'm just going to go 42 times 3.79 times 60. That's 9,550.8. And what am I left with? I'm left with liters, right? And I'm left with 1 hour, right? Because this is 1 times 1 times 1. No need to do that, right? So we're just going to say, hey, we're good to go here. Oh, I forgot to say this. Rates, different units, right? Maybe highlight that. So now I'm asking you something else. How many liters would be pumped? Let's assume this is a pump, right? It's pumping this many liters every hour. How many liters would be pumped in 5.5 hours? When you have something like this, it's asking you to extrapolate, right? To predict what's going to happen down the road if this is true, right? So watch what I do with this. I take this with me and I'm going to set it up like this: 9,550.8 liters in 1 hour. And this is different. I'm going to say equals to X number of liters in 5.5 hours. And sometimes students are like, when do you do this and when do you do the thing that we've been doing so far, where just times and things cancel out? I will tell you this: if you have a question that gives you part of it, so you have a rate that has liters and hours, correct? This one is telling you, hey, if this much time went by, what about the other one? Like if you have something that's saying it that way, you should set up a proportion. This is a proportion. I don't know if you remember. Fancy word for cross multiplying and dividing. I don't know if you remember that. But this is how I do proportions. Watch. I go to the variable, right? It's on the right side of the equation. I start with a number and I multiply across. This is just to show us what we're going to be doing. And you divide by what's left over. Works every single time. Okay? Probably not the way you've learned it in IPR, and that's okay. From time to time, I'll show you the exact way, the proper way, right? But it's 5.5 hours multiply 9,550.8 liters. And that's all divided by, right? So you multiply, always multiply first, then divide last. And what is going to cancel out? You have hours multiplying liters, and you have hours here. So this goes with that. Okay, hours go with hours. So all you're left with is liters, which is what you want, right? You know you're doing things right this way. Don't worry, we're going to do more of these. So clear my screen here for a minute. 5.5 times 9,550.8 divided by 1, which is irrelevant. And we are in liters, right? So this many liters will be pumped, right, in 5.5 hours. So I first converted gallons to liters per hour, right? And then I used that to help me answer the second part of the question, right? I'm debating if I should let you do the next one. Yeah, you try the next one. What's mph? Anybody? Miles per hour, not meters per hour. I have quite often students that on a test they kind of freeze a little bit. It's when it's mph, is miles per hour. If it's kilometers per hour or ms, meters per second, that's a different story, but this is miles per hour. So 65 miles in 1 hour, that's what that is saying. Okay? This part right here. So I want you to convert it to meters per second. See how you do. with what I've shown. 65 miles per hour. So I go like that, miles when it's standalone in 1 hour. And I want meters per second. So here's where it could be different. You might have done this different, so don't erase. Okay. I'm just going to say this. 1 mile has 1.6093 kilometers. Okay. And so this goes with that, but I'm still not where I want to be. So I'm going to say 1 kilometer has 1,000 meters. And some of you skipped that step because it could be that I gave you the conversion rate. I'm pretty sure I gave you that, but if not, this is how you would do it. Kilometers go, so I'm good now. I got my miles to be meters. Now I'm going to tackle the time. So I'm going to steal some space here. 1 hour. 1 hour has 3,600 seconds. Are you okay with that? You could go 1 hour has 60 minutes and then 1 minute has 60 seconds. That's fine. But I need some space here. So this hour goes with that. Oh my goodness, highlighters. Right? Miles went with miles. Sorry, miles, not you. This mile goes with that one. And then this hour went with that hour. Right? So you should be able to see one in the numerator, one in the denominator. Okay. And here's where, right, you multiply out the numerator to give you this. And here's another concept coming up. So you're down to meters and seconds. Okay. This is a rate. Still a rate. It's still a rate. And now I'm going to talk about the unit rate. When you divide them, so when you divide the top by the denominator, what do you get? 604.5 divided by 3,600. You get that. That is what we call a unit rate. 0.06 meters per second. And this is called a unit rate. And how do you know it's a unit rate? What is a unit rate? Aren't the units everywhere? Look at for the per 1 second, right? This one was per 3,600 seconds, right? But this one is per second, so that's actually a unit rate, okay? Which I'm going to highlight. Unit rate per 1 second. So when we're comparing which one is the better buy or who is faster, you want unit rates, okay? And all you do is to divide. We've been doing that so far. Okay, I'm going to do this. Just say whatever happens here answers that question. How long would it take to travel 750 meters? Oh, so there's a rate here, but then here they only give me one piece of that, right? So I would say use proportions. Which one, Mr. Erickson? Should I use this one or should I use this one? The answer is it doesn't matter in this case because this is part A and this is part B. You could actually use this one, but it's probably best to use this one here. I'm going to use 29.06 meters in 1 second. Why? Because my answer key has it like that, okay? So I don't want to get it wrong in front of the whole class, right? And so this is X number of seconds. That's how long it's going to take me. So remember that rule? Find your variable. Where is it? Right there. Start with the number. In this case, that's above it. So you have to multiply down, divide up. Okay. 750 times 1 divided by 29.06. How come you have no units, Mr. Erickson? Because I just showed you earlier that things cancel out. But you're guaranteed if you do this way that you're going to get your answer in seconds. And I get 25.81 seconds. And again, that's how I do it. You can try doing it your way, and if it matches my answer, you're probably all right. I'm just going to give you the answer to this one. This one is 2.53 ounces per second. And this would be 157.5 liters. If you want to know, if you want to try this on your own, you go for it. But I'm running out of time here, so I'm just going to leave it at that. I think I'm ready to just, let me just check here one. I'm just going to leave it at you having to do page 4 for homework. So go to page 4 and just say homework, page 4. Right? And I see already some hiccups here and there. If you look at the bottom of this page, what does it say there? Homework, page 3 of the workbook. And you're like, what workbook? Isn't this a workbook? This used to be a single handout, and so sometimes I forget to remove these things. So just cross this out so you're not confused. And this page I'm going to post on Google Classroom, and you'll be able to see worked out, not just the answer. You're going to see the whole thing worked out as a PDF so you can check if you're doing things right. Okay, I'm going to stop here because Friday, right? Don't want to push it right to the end. Sometimes I do.